Hello, my dear students. Come to the live session. Today, we are going to discuss about factors affecting the rate of reaction. So, this is useful for those who are preparing for EAPCET examination and as well as NEET examination. Factors affecting the rate of reaction. Say, look, my dear students. So, what factors are influence the rate of reaction? So, first of all, yesterday we are discussing about the rate of reaction, right? So, what is the rate of reaction? Rate of reaction, nothing but the change in the concentration of reactant or change in the concentration of product by progressing time is called as rate of reaction. So now we have to discuss factors affecting the rate of reaction. Factors affecting the rate of reaction. Rate of reaction. So what are the factors are affecting on the rate of reaction that we have to discuss? See, look, my dear students, is that visible? Is that visible? Is that visible? Factors affecting the rate of reaction, right? See, what are the factors are affecting on it? So which factors are affecting on it? The rate of reaction can affected by 7 factors. Rate of reaction can affected by or can influenced by 7 factors. 7 factors. What are those? So number one that is nature of reactants. Nature of reactants. Number 2, activation energy. Activation energy. That is EA, activation energy. So number 3, my dear students, that is directional nature of reactants. Directional nature of reaction. Directional nature of a reaction. Then number 4, concentration of reactants. Concentration of reactants. Number 5, effect of temperature. Then number 6, catalyst. So number 7, radiation. This is for photochemical reactions. Photochemical reactions key. For photochemical reactions, it is useful. See, these 7 factors are influencing the rate of reaction. So one by one, we have to discuss. First one, the nature of reactants. Second one, activation energy. Third one, directional nature of reactions, not reactant, reactions. Then concentration of reactants, then temperature, a catalyst, then radiation or photochemical reactions. See, look, my dear students here. So first, what is the nature of reaction that we have to discuss? The 7 factors low, first factor we are discussing, that is nature of reactants. In nature of reactants lo, first one manam discuss cheyalsindi the physical nature of reactants. See, look, my dear students. So first factor we are discussing nature of reactants. In that first one, physical nature of reactants we have to discuss. The physical nature or physical state. So physical state of any reactants, we can actually any substance can exist in the 3 physical states: gas, liquid, solids. So here the rate of reaction based on the physical state, order of the rate of reaction based on the physical state, gases are more reactive when compared to the liquids and as well as solids. See, look, my dear students, the order of rate of reaction based on physical state. In case if you take, gases are more reactive than that of liquids, than that of solids. Gases are more reactive than liquids, than that of solids. See, look, my dear students, here in case if you take, we have to discuss about the solids in case of. Sir, in case of solids, if you take, in case of solids, the rate of reaction is depends upon the size of particle. So in case of solids, rate of reaction is inversely proportional to size of a solid particle. Size of solid particle. See, that is what we can say for the solid reactions. Then solid, when it is present in the powdered state or finely divided state, the more reactive and comparative to liquids and as well as gases also, because it is depends upon the surface area. So surface area increases, then rate of reaction increases. So here it is depends upon the, for solids it is depends upon the size of solid particles. See, look at solids in finely divided state, or powdered state, finely divided state or powder state. So more reactive. So why more reactive? Because surface area increases. Rate of reaction increases. So this is about the physical nature of reactants. So in the physical nature of reactants, if you take based on the physical state, the gases are more reactive than that of liquids and as well as solids. In case of solids, if you take, so it is depends upon the particle size. Then particles of size is less, then rate of reaction increases. So that is what solids in finely divided state or powdered state. So more reactive, that is rate of reaction is greater. Why? Because the surface area increases, the rate of reaction also increases. Yes, understand, my dear students? So next we have to discuss about the physical nature of or chemical nature of reactants. So in the nature of reactants, first we are discussed the physical nature of reactants. The next one, chemical nature of reactants have to discuss. So how the chemical nature of reactants, it will be depends. That is chemical nature of reactants. So how the chemical nature is depends. See, look, my dear students. So when the comparative to ionic reactions and covalent reactions, the rate of reaction of ionic reactions are greater than that of rate of reaction of covalent reactions. See, why? What is the reason ionic reactions of rate of reaction is greater? Because In the ionic reactions, only ions can be exchanges. Only ions can be exchanges which do not involve bond breaking or bond making in the reactions. So note that point, my dear students. For ionic reactions, rate of reaction is more because the only thing, that is only ions exchange takes place which do not involve bond breaking or bond making. See, for example, AgNO3 solution which is present in the aqueous state, then NaCl solution which is present in the aqueous state. Then both, when it is reaction, this is the fast reaction actually. Fast reaction. See here, Az is a plus, then NO3 is a minus charge, Na plus charge, then Cl minus charge. Here ions only exchanges takes place. Then Az plus can take other molecule of negative charge, that is Cl. Then here precipitate is formed. Then the remaining Na plus, by taking of other molecule of NO3 minus, then NO3 minus will be formed. So only ions are exchanged. So that is what this reaction is, a fast reaction. In case if you take for the covalent reactions, so I told that covalent reactions of rate of reaction is less than that of ionic reactions. For covalent reactions, rate of reaction is slow than ionic reactions. Because, what is the reason? Because here a bond breaking and bond making both are involving. Bond breaking and bond making nothing but formation. Bond making are involved in these reactions. Look, my dear students, in case if they will ask a question, which of the following is more rate of reaction, or which of the following is fast reaction, or which of the following is a slow reaction. So based on the chemical nature, we can say which are ionic compounds, which are covalent compounds. Based on that, we can say. So for example, some of the covalent reactions, in case if you take, that is CH3 bond OH, then plus CH3 bond C double bond O, then bond OH will be there. So here bond breaking is taking place. Then even here also bond breaking takes place. Then then CH3, then C double bond O, then OH, then H attach with each other. Then H2O will be formed. So bond breaking, new bond making, new bond is formed. Then C double bond O, then it will be connected with OCH3, then OCH3. Of course, it is a ester formation takes place. In the formation of ester, what happens? Bond breaking happens. Then in the both cases, bond making happens. Nothing but new bonds are formed. So that is what here the time taking. So time taking for this reaction. See, look at one more example. So here one of the example is there. 2NO when it is reaction with O2. So here how many number of bonds are there? So in each molecule 2 bonds are there, but 2 molecules are there. 2 is a 4. So 4 bonds are present in it. Then here O2 molecule only 2 bonds are present in it. Then once both formation taking place, then NO2 will be formed. So that is 2 moles of NO2, N double bond O, then single bond O, like this will be formed. Then 4 bonds plus 2 bonds, totally 6 bonds are formed. 6 bonds are formed. See here. So here how many bonds are formed? So in each molecule 3 bonds are there. 2 bonds here, then 1 bond here. Then 3 molecules. But how many molecules are there? 2 molecules. 3 bonds into 2 molecules. Totally 6 bonds are present. 7. Here 6 bonds are breaking. Here 6 bonds are making. So that is what rate of reaction is very slow. So this is a slow reaction when comparative to above one. So here only 2 bonds are breaking. Here 2 bonds are making. But here 6 bonds, then 6 bonds are breaking and 6 bonds are forming. So one more reaction, the second reaction in case if we take, that is C triple bond O, then C triple bond O, then 2 moles of CO, plus then O2, then O double bond O. Then see, look at here how many bonds are there. So each molecule 3 bonds, 3 2s are 6 bonds are there. Then here how many bonds are there? 2 bonds are there. How many bonds? 2 bonds are present. Then when both reaction with each other, the 2 moles of C double bond O, then double bond O. Then in each molecule 4 bonds are present, 4 2s are 8. So 8 bonds are present. 8 bonds are formed. So here 8 bonds are breaking, here 8 bonds are forming. So that is what when comparative to the second reaction, this is very slow. So this is very slow. So in case if they will ask based on both, which is more rate of reaction, which is less rate of reaction. See, look my dear students, the rate of reaction of first one is greater than that of rate of reaction of second one. Because what is the reason? Sir, here only 6 bonds are forming or 6 bonds are breaking. Then here, but 8 bonds are breaking and 8 bonds are forming. So that is what we can say the chemical nature of reactants. So one factor we are discussed, that is chemical nature of reactants. So next we have to discuss, my dear students, the chemical nature of reactants, the physical nature of reactants, both are done. Next we have to discuss activation energy. Activation energy. See, look my dear students, how the factor activation energy is effect on rate of reaction. So second factor is activation energy. That is, we can represent with EA, activation energy. So remember, rate of reaction generally, rate of reaction or rate constant are inversely proportional to the activation energy. Inversely proportional to the activation energy of reactants. See, look, my dear students, how can you find out the activation energy? So first of all, what is the activation energy? Activation energy ante enti? Activation energy means the minimum extra amount of energy is required by reactant molecule in order to convert product. In order to convert a product, that energy is called as activation energy. So what is the activation energy? The minimum extra amount of energy is required to convert, in order to convert product required by reactant in order to convert product is called activation energy. Activation energy. Yeah, look, my dear students, this is the activation energy. So how can you calculate the activation energy actually? See, the activation energy with a progress of time, the graph if you take, then energy, not activation energy, energy and progress of time if you take, then here the energy of reactants are there, then it can get some energy that we call activation energy, then products are formed, so this is energy of product. Clear, my dear students? So from the 0 to, so here whatever the energy difference is there, this we call threshold energy, ET. See, remember ET nothing but threshold energy. Threshold energy. See, ET that is. So this is energy of reactants. So actually some of actually reactant molecules having some of the energy, right? So up to here the energy will be there, means some of the energy is there. So minimum extra amount of energy, so extra amount, sir, activated complex, the formation of activated complex, that is we call activation energy. Activation energy. So this is in case the reaction is going from reactant to product, this we call activation energy of forward reaction. Sir, even products also having the activation energy. Products also having activation energy of backward reaction we call, in case product can be converted into reactant if it is reversible reaction. Clear, my dear students? So look, so this is energy of reactants, this is energy of product. The energy gap between the energy of reactants and products is called as delta H. See, this is the product I told, product having the minimum energy and a less energy, then reactant having more energy. So energy of products minus energy of reactants if you take, so energy of reactants are greater, so greater the value having negative charge, so you can get negative. So that is we call endothermic reaction, sorry, exothermic reaction. Exothermic reaction. So this is exothermic reaction. So exothermic reaction not only based on the energy of products and energy of the reactants, we can also calculate activation energy of forward reaction minus activation energy of backward reaction. So that is what delta H. See, so what is the activation energy? So minimum extra amount of energy is required for the reactant molecule can be converted into product molecule. That is what activation energy. So this is the reaction, this is the graph for exothermic reactions. Look at, my dear students, for endothermic reactions in case, then energy of reactants having some energy, then the product, this is, so these are energy of products, then these are energy of reactants, then this is the minimum energy, this we call, I told that, so energy of a activation energy of a forward reaction, this is activation energy of a backward reaction. Clear, my dear students? Then from here to there, this is ET, nothing but threshold energy. So that I told, threshold energy. Clear? So now energy of reactants or products with a time if you take. So even here also we can find out the delta H value. See, look at this is the energy of products, EP, then this is the energy of reactants. The energy gap between the products and reactants is called change in the enthalpy of reaction. So enthalpy of products minus enthalpy of reactants if you take, you can get positive value here, because then enthalpy of products are greater, that is a positive value. So that is what we can get a positive. So this is endothermic reaction. Endothermic reaction. See, my dear students, activation energy is greater. Activation energy is greater, then rate of reaction is less. So based on that, we can say where rate of reaction is greater, where rate of reaction is less. So note down both endothermic and exothermic reactions of the graphs, so which are very important to you. Yeah, previous what we are discussed that the ionic reactions, when we are discussing about the rate of reaction of ionic reactions and covalent reactions, rate of reaction of ionic compounds are greater than that of rate of reaction of covalent compounds, I told. So reasons I told that in the ionic reactions only ionic exchanges takes place. Then in the covalent reactions bond breaking and bond making takes place. That's what it will take time. So that's what the rate of reaction is slow in the covalent reactions, I told. But based on the activation energy, in case if you say, for ionic compounds, activation energy is less, so that rate of reaction is more. For covalent reactions, activation energy is more. Activation energy is more, so that rate of reaction is slow. So because both are inversely proportional. Clear, my dear students? See, look at what I told based on the activation energy. So in case for ionic reactions, activation energy is less. So that ionic reactions of rate of reaction is fast. Then for covalent reactions, activation energy is more. So that rate of reaction, so that covalent reactions of rate of reaction is slow. Clear, my dear students? Then we can say the one of the reaction, that is KMNO4. The KMNO4, when it is treated with oxalic acid, that is H2C2O4, in the presence of acidic medium H2SO4, in the presence of acidic medium, then the reaction, see, look at K2SO4 will be formed, plus 2MnSO4 will be formed, plus 10 moles of CO2 will be formed, plus 8 moles of H2O will be formed. To balance that equation, we are taking here 2, then here we are taking 5, then here we are taking 3. Right. So whatever it may be. So look, my dear students, this reaction is slow. At room temperature. But the same reaction at 80 degrees Celsius, rate of reaction is fast. At room temperature, rate of reaction is slow. So rate of reaction is slow at room temperature because the only thing is activation energy is greater. So for this, activation energy is greater. So for this, at this temperature, activation energy is less. So activation energy is less, then rate of reaction is more. Understand, my dear students? So this is based on the activation energy. So first of all, what is the activation energy? The minimum extra amount of energy is required by reactant molecule in order to convert a product. That energy is called as activation energy. Activation energy always is inversely proportional to the rate of reaction and as well as inversely proportional to the rate constant also. This is second factor which is influenced by the rate of reaction. So next third factor that is directional nature of reactions. That is directional nature of reactions. Third factor, directional nature of reactions. I told directional nature of reactions. So in this case, that three different cases we have to explain in this. Sir, one is case number one. Case number one, the rate of reaction of irreversible reactions. Irreversible reactions. For irreversible reactions, nothing but the reactions are only unidirectional. For example, a common reaction, that is A plus B, can be converted into C plus D. So only one direction. So reactants can be converted into products. So reactants products ga convert avutayi, product reactant ga convert avadu. That type of reactions we call directional reaction. Irreversible reactions. For the irreversible reactions, in case if you observe, the rate of reaction depends upon the concentration of A, then concentration of B. So concentration of A and B decreases. Rate of reaction also decreases, right? Okay, clear? See, remember the rate of reaction for the irreversible reactions, then concentration of A and B decreases, the rate of reaction also decreases, right? For irreversible reactions, rate of reaction decreases due to concentration of reactants decreases. Okay, clear? Yes. Sir, case 2, in case if you take case 2 when it is observed, these are case 2 for reversible reactions. For the reversible reactions. So reversible reactions, nothing but the same reaction I'm taking. So A can be converted into the B, then B can be converted into A. See here the rate of forward reaction, in case if you take, then Kf into concentration of A, it is depends on that. Then the rate of backward reaction, if you take, so Kb into concentration of B, you can take like this. See, rate of forward reaction decreases, rate of backward reaction increases because concentration of B increases for the reaction, right? So for in case if you take for these, graph for this, the concentration of A with respect to time, if you take the concentration of A and B are the concentration, simply you can say. So with respect to A, in case the concentration exponentially increases, we know that. Then concentration of product, in case if you take, that is B, if you take, then that will be decreases. So same for the same reaction, in case the concentration, it may be in one particular time at equilibrium time. So that is concentration of both reactants and products with respect to time. So it is at equilibrium. So at equilibrium, here concentrations are equal. At equilibrium, here concentrations are constant. Then here straight it can get. See, remember, my dear students, for the equilibrium reactions, when equilibrium is established, concentration of reactant and product is constant. Concentration of reactant or product is constant, but it is not equal, not exact. It may be equal or may not be equal. So may be equal or may not be equal. So these are the concentration. Yeah, clear, my dear students? See, whatever it may be, here for the reversible reactions, in case overall rate of reaction, if you want to find out, the rate of backward reaction minus rate of forward reaction, you can find out. So based on that, we can say, irreversible reactions, rate of irreversible reactions are greater than that of rate of irreversible reactions are greater than that of rate of reversible reactions. So because, so both forward and backward we should consider in this case, but here only the forward direction we can consider in this case. So that is what irreversible reactions, rate of reactions are greater. Clear, my dear students? Yeah, one of the example I will give to you people. That is the decomposition or dissociation or saponication of esters. The hydrolysis of esters in the presence of acid and base, if you take. So that is CH3 bond C double bond O C2H5 ester by the addition of H2O in the presence of acid, if you take, my dear students. See, look at all of you. Yeah. So this reaction. So what happens there? CH3, then C double bond O, then OH plus, then C2H5OH. So this reaction actually, in the presence of acidic medium, it is a reversible reaction. Then the same reaction in the presence of a base, the addition of H2O in the presence of a base, OH minus, it is irreversible reaction. Nothing but the same products will be formed, CH3, C double bond O, OH plus C2H5OH. Look at, my dear students. So reaction 1 is reversible, reaction 2 is irreversible. Reaction 1 is reversible, reaction 2 is reversible. So wherever the irreversible reactions are there, so rate of reaction is slow. So the rate of reaction is fast. Rate of reaction of irreversible is greater than that of rate of reaction of reversible. That is what I told. So this is the second case. Then third case, if you observe, my dear students, the third case, which is case number 3, that is for zero order reactions. For zero order reactions. See, for the zero order reactions, rate of reaction is constant. Rate of reaction is constant when time is going progress. So at the end of reaction, it will drop to the zero. Rate of reaction actually constant for the zero order reactions, but at the end of the reaction, it will drop to the zero. So note down that point. For zero order reactions, rate of reaction is constant. But at end of reaction, it will drop to 0. It will drop to 0. See how it is, why it does not depends upon the concentration. So because it is a zero order reaction. So R equals to K into, in case concentration of A is there, A power 0. So once A power is 0, then R equals to, rate of reaction equals to constant. See, that is what I told, it is constant always. See, in case if you take graph for this, rate of reaction versus with respect to the time if you take, then I told that rate of reaction is a constant. At the end of time, in case of particular time, it will be end, then it will be dropped to the 0. So rate of reaction is constant. At the end of the reaction, it will drop to the 0. It will drop to the 0. But in case if you take concentrations, man, definitely the concentrations are decreases. The decrease in the concentration of reactant for the 0 order reactions are linear manner, I told. For other order reactions are exponential manner, it will be decreases. See, that is what I told. For the 0 order reactions are rate of reaction constant. Then at the end of reaction, it will be dropped to the 0. So all these reactions you have to remember, my dear students. So this is directional nature of reactions. Next factor that we have to discuss about the concentration, effect of concentration of reactants. The fourth one, effect of concentration of reactants. Effect of concentration of reactants. So wait, my dear students.